Hi, everyone. Welcome. This is the YugabyteDB 2.7 Spotlight Showcase webinar. We have a packed agenda for you. I'm going to see how we're going to fit everything in the hour that we have because there's so much in the 2.7 release. That being said, we want to make sure that we are taking your questions and answering them on this call. So if you have any questions, please use the chat and we will try to get to it on the call. If not, we will follow up with you because that's the most important part of this. We want to make sure it's a discussion. Before we get started, very quick introductions. My name is Suda Srinivasan. I'm the VP of Solutions at Yugabyte. I've been in B2B tech, enterprise tech for the past 15 plus years. I've been an engineer, product person, product marketing, evangelism, BD, worn many hats. I've worked at Nutanix, Deloitte, started my career as an engineer at Microsoft in the operating systems division, and I've worked at a bunch of startups. I have with me here illustrious product VP, Amey Banarse. Amey, over to you.
Thanks, Sudha, for the quick introduction. So for folks, I'm Amey Banarse. I'm leading the product here at Yugabyte. Been with Yugabyte for about 2.5, 3 years now. And previously, I was at Pivotal, where we led the advent of microservices for all the Fortune 500 companies. And previously, it was New York Stock Exchange and FINRA. So my team is basically focused on gathering data from different stock exchanges and really catching the insider traders in some sense. Great seeing all of you here. Thanks for taking the time and attending this webinar. We hope this will be amazing content for you. And last but not the least is that we are an open source company. So everything that we showed you today is absolutely available on our GitHub. And we are ready to get your feedbacks in and make sure we make progress on the product as well.
Perfect.
So let's start.
Let's get started. So just in terms of format, it's going to be a lot of back and forth between Amey and me. We have slides, we have demos, we have benchmark results that we want to show you. So quick introduction. I'm hoping that everyone on this call is familiar with YugabyteDB, but if not, here's a very quick update on who we are. YugabyteDB is an open source distributed SQL database. We are built for transactional applications. So large scale transactional applications that require resilience and scalability. YugabyteDB is 100% open source, as Amey mentioned. So everything you're seeing here is going to be available. You can go check our docs at any time. They will be up to date with all these features. And YugabyteDB is designed to run in any cloud, right? So I'm going to repeat that. It's like bare metal, on-prem, hybrid, any cloud that you have, containerized, virtual, YugabyteDB is designed to run there. We are 100% Postgres compatible. We are the most PostgreSQL compatible distributed SQL database around. So the way we do that is we reuse the upper half of Postgres directly. Rather than rewriting it, we are actually reusing that code that allows you to basically port your Postgres applications over to Yugabyte with pretty much no code changes required, right? And under the hood, YugabyteDB is a distributed database. So it's built for resilience, high availability, horizontal scalability, and geo-distribution, right? So you get all the goodness of a relational database. You get ACID transactions, distributed ACID transactions. You get all the relational semantics, but you also get the resilience, scale, and high availability and geo-distribution of a cloud-native architecture. So that is YugabyteDB in a nutshell for you. Now, as part of the 2.7 release, now, again, the other thing I want to mention is YugabyteDB has been supporting Kubernetes. So you can deploy YugabyteDB in Kubernetes environment. We have supported it since pretty much the beginning. But one of the themes that we chose for this release was how YugabyteDB 2.7 offers the most comprehensive coverage of Kubernetes environments for microservices. So what we're going to do in this webinar is talk about why this is true first. Like what are the things that what are the new improvements, new capabilities, certifications, and so on in this release that makes it true. Then we will also talk about some of the new features that came out in 2.7 that are exciting for both developers and operations teams. So YSQL table spaces, point-in-time recovery, sync connector for Kafka, encryption and transit using TLS. That's been around, but we actually did some very interesting performance benchmarking there. And then the Yugabyte platform, high availability. So with that, let's jump into the first one, right? Kubernetes. This is one of the big themes because there's a lot that has happened in this release, specifically around supporting Kubernetes environments and microservices running in Kubernetes environments. So taking a step back, I think this is something we're all familiar with. There was a study that VMware had done recently, and they published a report called the State of Kubernetes Report, definitely worth a read, that talks about substantial growth in Kubernetes usage, especially in organizations that have traditionally been laggards in terms of adoption, right? So large enterprises that have been more risk averse are actually seeing the benefits that containerization and Kubernetes is offering in terms of portability and ease of use and automatic scaling and so on. So we're actually seeing increasing use of Kubernetes in production environments, right? So more and more companies are looking at how they can move not just their stateless applications, but also stateful applications into Kubernetes, into production, right, in Kubernetes. And this is something that, while there are still some pain points, most developers and executives feel like Kubernetes is worth it at this point. So, Amey, do you want to add something to that?
Sure. So one of the key highlights from the VMware report, the VMware 2020 State of Kubernetes reports, is that today a lot of Fortune 500 enterprises are actually putting their business critical applications on top of Kubernetes. That includes both stateless microservices as well as stateful applications. And it's proven now that Kubernetes is a conducive runtime to run these stateful applications like Yugabyte at scale. It provides you the complete automation as well as a full control in terms of how you deploy, lower the latency. Obviously, networking sometimes becomes a challenge, and that is something that Kubernetes and CNCF is actually working on solving that. So stay tuned for our KubeCon. I mean, we had a really good presentation at KubeCon just 2 weeks ago, as well as like few things that are coming in the hopper as well.
Yeah. And so when it comes to Kubernetes, right, there are three things that still remain kind of thorns or pain points, roadblocks for broader Kubernetes adoption. One of them is portability, right? So you have open source Kubernetes, but then you also have a lot of different flavors of Kubernetes offered by the cloud providers, offered by other companies. So one of the questions, even though Kubernetes and containers kind of offer you the portability, actually ensuring that your workloads run in all these different flavors of Kubernetes and Kubernetes environments is something that a lot of enterprises kind of think twice about. The second piece is performance, right? People are worried about I/O on top of, within pods, on top of in nodes and so on. So that's the other question. How is your workload able to perform on par as they would in a virtual environment if they're running in a containerized environment and in Kubernetes? And the third one is, infrastructure operations, right? So you're running your containerized environments on top of infrastructure. How do you scale it? How do you scale up, scale down? How do you deal with resilience? How do you deal with networking when you're deploying your workload, or like your database, in a geo-distributed fashion, right? Multiple regions or even multiple clouds. How do you actually deploy this and manage networking and so on? So we talked about portability, performance, and infrastructure operations. So we will look at how 2.7 addresses each of these three as we go forward, right? So Yugabyte, again, we are a very versatile database that can be deployed in pretty much any environment of your choice. So AWS, Google Cloud, Microsoft Azure, VMware Tanzu, OpenShift, and so on. And Yugabyte platform gives you a very convenient way, very comfortable way to manage and streamline operations of your YugabyteDB clusters across all these different environments, right? And I may add about platform, because I know that's something you're passionate about.
Exactly. So folks, as you understand, the founding roots of Yugabyte are from Facebook. So our team basically built Cassandra and HBase inside Facebook for parts of Facebook Messenger and other Facebook projects. The way they were successful is by relying on database reliability engineering principles. And that's exactly the value that we bring to you all through Yugabyte platform. That is, Yugabyte platform is a containerized web application that can be deployed on any form factor, virtual machines, bare metals, or Kubernetes, and it provides you a seamless way of deploying and managing Yugabyte universes or clusters at scale across different cloud providers, as Sudha is showing you, or even your own on-prem data centers. So you can have virtual machines with Nutanix or VMware or Dell bare metal systems, and you get the same exact seamless experience of deploying Yugabyte. And we comply with a lot of CNCF.io best practices when it comes to manageability, observability, alerting, and metrics. So we use Prometheus, Grafana, and a lot of other tools to make sure you get the same exact seamless experience and extensibility as well.
Perfect. And so the way it works, right, just to quick recap, YugabyteDB is a distributed database. So you deploy YugabyteDB as a cluster of nodes, right? And these nodes talk to each other to present a single logical SQL database to the application layer above, right? So it looks like a single database, but behind the scenes, it's a distributed system. each node in a YugabyteDB cluster logically has two layers. You have the query layer, which is actually getting inbound queries, and then it's doing query optimization and so on. And then you have a storage layer that is actually storing the data, right? So both of these together form what's called a YugabyteDB node. Now, in a containerized environment, you deploy YugabyteDB nodes in pods that are running in worker nodes, and you can basically set anti-affinity rules and so on, so that you're distributing your YugabyteDB processes so that there is no single point of failure and there is high resilience in the system, right? We'll quickly talk about some of the things that are provided by this architecture. Pod failures, as you know, are handled automatically by Kubernetes. So if a pod goes down, the processes within that are spun up in a new pod once that is brought back up. If you have node failures, then these node failures need to be handled manually by adding a new node in a Kubernetes cluster. Of course, if you're using one of the cloud flavors like ECS or EKS, that is done automatically for you as well, right? And built-in pod anti-affinity, as I said, you don't want to have two nodes or two logical, what we call Yugabyte YBT server, which are the actual worker processes. You don't want to have both of them on a single node, because if that node goes down, then you have a single point of failure, right? So you basically distribute it across the nodes in a cluster so that you're getting the highest level of resilience possible from the underlying infrastructure. And then day two operations, again, Yugabyte is designed to very simply scale up and scale down seamlessly, right? You can just add Yugabyte nodes as you go and scale the number of connections, scale the throughput, and scale the available storage capacity in the cluster very seamlessly, right? Just single click and you're up and running. Rolling software upgrades, again, YugabyteDB is designed for zero downtime rolling upgrades, again, following DBRE best practices. So basically, you have a cluster that will continue to run even as software upgrades are being done on it. And as Amey had mentioned earlier, observability with Prometheus and Grafana and built-in alerting. So you're getting eyes in the cluster at all times and all the metrics that you need to make sure that your cluster is in a healthy state. Right. And then finally, on the data protection side, we have backups and restores available at the database level, and YugabyteDB can perform distributed snapshots. So if you have, again, if you have tables that are spread out across multiple nodes, you can perform distributed snapshots and copy that to an S3 bucket, keep it off cluster, right? And finally, as we're going to talk about in this release, we have point-in-time recovery that allows you to roll back to a specific point in time in the past to recover from unintentional errors or some kind of data corruption. So a lot of rich capabilities to make the process seamless and to simplify your day two operations and kind of day-to-day running of the Yugabyte in a containerized environment.
Right. And Sudha, just to add there, right, we were fortunate enough to being born in the cloud native era where these things were a norm while building a brand new stateful database, right? And that's why all of these are out of the box from Yugabyte and they are not an afterthought. That is, when it comes to day two operations, we routinely have customers who deploy 80 or 100 node Yugabyte clusters at scale and are able to manage it without any downtimes or issues. We had a very large customer, a Fortune 5 company, who had their entire data center taken out or one entire region of Yugabyte taken out due to Texas power outage. It had no performance impact or downtime to their end customers for next 4 days when they were trying to go and resurface the data center. So again, these are the things, cloud native best practices that we have already built into the database so that you can go and run your business critical applications without any operational overhead on top of your DBA teams.
Perfect. And since we mentioned RF3 in this slide here, I'll just make a very quick side note to say, all tables, all the data in Yugabyte is automatically sharded, right? So YugabyteDB automatically shards the data and puts each of those shards, we call them tablets, it distributes them across the cluster, right? So you don't have a single node where everything is sitting. And this distribution happens in such a way that each data copy, like each shard, is replicated depending on the replication factor. So RF3 means that there are 3 copies of that particular shard in the cluster. So when we talk about affinity, anti-affinity, the other thing is making sure that the data is also distributed across the entire cluster for resilience. Okay. So going back to a point we talked about in portability, right? Everyone, Yugabyte loves Kubernetes. We've been big fans. We've been deployed in Kubernetes environments, tested in Kubernetes environments. One of the things we've seen, especially with enterprises, is they all have their favorite Kubernetes platforms, right? So this could be one of your cloud platforms like EKS, ECS, AKS from Azure Kubernetes, or GKE. It could also be just your open source, Kubernetes, a CNCF Kubernetes project that they're deploying in their data centers. It could be OpenShift or VMware Tanzu, which gives you a lot kind of Kubernetes plus a lot of orchestration and app development services and so on. Could be Cast AI that you use to coordinate multi-region deployments and manage infrastructure and so on, or Robin or Weaveworks. Pretty much across all of these, we have customers today who are deploying Yugabyte. This has been tested and running and is supported, right? So it is something that you can rely on. So the question of portability is one that we are addressing upfront because we know that people want to pick kind of the Kubernetes flavor of their choice. And so go for it. Now, that being said, we announced, I think last April or May, we announced our support for VMware Tanzu, and we announced that YugabyteDB was certified by VMware Tanzu, right, to run on VMware Tanzu. In 2.7, we've done a lot of work to further that relationship and that integration. I might walk us through what's new in 2.7 for this.
Perfect. So what we have done, team, is that we've collaborated with VMware Engineering to essentially certify Yugabyte as a distributed SQL database on top of their entire Tanzu portfolio. That includes VMware Tanzu Grid or VMware TKGI multi-cloud, or even VMware vSphere that is built in with Kubernetes. That's the most innovative product that VMware has currently built on. And to ease out the experience, we are now listed on the VMware marketplace itself. You can essentially go to marketplace.vmware.com/Yugabyte, get the bits and hook up to your CI/CD pipelines and continuously deploy Yugabyte on top of your any VMware environment. And to again ease out a few things, we make sure that Yugabyte platform is the central way to go and manage any number of Yugabyte universes at scale, whether they're running on your existing VMware 3-rack in a single data center or across multiple different data centers as well. You get the same exact experience. So a lot of innovation has gone in this one. And the reason we've certified this because now you have both VMware and Yugabyte standing next to you so that you can confidently run your entire workloads on top of these cloud native runtimes. And again, this is something that, Pat Lee, who's a vice president at VMware, essentially provided us this code saying that VMware and Yugabyte have been working really hard together and partnering to make sure that customers and users can confidently run their business critical microservices on top of VMware and provide a low latency, high throughput access to stateful workloads like Yugabyte. So that way, you don't have to worry about any networking challenges or any runtime challenges. You have one single runtime to go and manage both stateless and stateful applications. So again, VMware is present in almost all of the Fortune 500 companies. So it's a very important partner for us to work with. Similarly, on the next slide that you see, we have collaborated with Red Hat as well. So today, you can go to marketplace.redhat.com and deploy Yugabyte on top of any of your OpenShift environments. Now, to foster this relationship, we actually worked on something innovative with Red Hat. So for the last 4 to 6 months, our R&D teams collaborated to create something called as Yugabyte Platform Operator. And this goes, so that if you can move to the next slide, this essentially talks about the innovation that goes in creating a custom resource definition. That is CRD, which is a first-class construct in Kubernetes. We essentially took those principles and created Yugabyte Platform Operator, piggybacking on the Kubernetes operator concept. And this basically provides you a seamless way through the Platform Operator API to go and deploy Yugabyte Platform and then manage your Yugabyte universes at scale. So again, we are bringing in innovation when it comes from the Kubernetes side of things as well. That is, now you have Platform Operator, which is essentially nothing but Helm chart deployment consisting of stateful sets, and that's how Yugabyte gets deployed. And we adhere to all the best practices that are available in the Kubernetes ecosystem to make sure you can confidently run your system of record workloads on top of Yugabyte while deployed on OpenShift as well. So if you look at the next slide, so the Lars Herman, who's again a VP from Partners Ecosystem at Red Hat, essentially gave us this code that we have been working together for the last 6 to 8 months to go and pursue this opportunity. But at the same time, customers can now truly run their microservices on OpenShift and stateful workloads on OpenShift. This provides them minimal amount of latency and very high throughput. And Again, Yugabyte has been tested at scale, so we can routinely do upwards of 10 terabytes per node easily on virtual machines or bare metals or containers. So that is a scale that Yugabyte really operates at.
Perfect. Thanks, Amey. So the one thing I want to call out, right? Both of these, VMware and Red Hat, they're probably the most popular enterprise Kubernetes platforms that go beyond. There's Kubernetes and containerization, but they have also become these platforms for building and delivering microservices, Spring applications in the case of VMware. So partnering with them is both a way for us to say, hey, we are integrated from a technology perspective, we are certified. So these companies have tested our solutions together and they're saying, we are giving you the optimal configuration, but you also have these companies now standing behind the solution. So if you've got, we actually very routinely are design partners working with our customers on their database transformation journey, right? If they're thinking about building microservices, want to think about how to migrate their databases over, talk to us, because we have been working with companies on how to kind of modernize databases to work in a microservices world. So there's a very good complementary story here.
So what we have done is, as you saw from Sudha's talk track today, that is, we are proven as a first-class citizen to go run on any runtime. And that was our whole philosophy while building this database in a cloud-native era. But just to make sure that we stick by our current core design philosophy, we routinely run our CI/CD pipelines, and our dedicated performance engineering routinely runs TPCC and YCSP benchmarks across Kubernetes and VMs and bare metals. So this is a quick snapshot of when you deploy Yugabyte on, let's say, Amazon Web Services, like, on VMs versus on GKE, what are the TPCC numbers looking like? That is, if you look at a quick snapshot here, again, the performance impact is pretty minimal. Like the efficiency for the VMs for the same workload is 97.96 versus in GKE it's 95.64, which is pretty good considering a bit of overhead when it comes to running containers on top of VMs and all those things. And it's proven at scale as well. So we can now confidently say that our performance parity is really, really good in terms of running it on containerized or virtual environments in that sense. So Sudha, anything else you want to add on that one?
Yeah, I would say, the performance parity is something that is key, right? You shouldn't have performance be an important factor in deciding whether you're going to deploy it in containerized environment or virtual. And so achieving this performance parity, what we are seeing here is kind of the outcome of a lot of product work that happened under the hoods to make sure that we are achieving this. And we're talking about like being within 5% delta of each other, right? Correct. Virtual and containerized. So that's a big outcome for us.
Correct. And we encourage all of our users to go try out their own TPCC benchmark. So we have created a dedicated repository on github.com/yugabyte/TPCC, where you can just go and redo all these tests on your end as well. And you can join our performance channel on Slack to make sure that you share your numbers as well. Now, with that as a theme, we also worked with this innovative company out of Europe, which is called Cas.ai, which essentially is, so they're bringing in multi-cloud Kubernetes as a core first-class concept to the enterprises. That is, with Cas.ai, you can confidently go and deploy your different Kubernetes environments and manage them in a single pane of glass. But we have now worked with them to make sure that Yugabyte can also be deployed in a similar way in a multi-cloud Kubernetes environment. And these are some of the numbers that Cas.ai and Yugabyte teams have collaborated to come back with. And as you can see, we do fantastically well, even in a multi-cloud, hybrid cloud deployment topologies as well. Because end of the day, Yugabyte has been designed with those principles so that you can provide strong consistency, even in multi-cloud, multi-region kind of deployments as well. So please take a look at Cas.ai. Again, a really innovative company. They're bringing a lot more innovation to the Kubernetes side of things that other vendors are still trying to get onto from that standpoint.
Awesome. Thanks, Amey. And we do have, so we had a distributed SQL summit session presented by Cas.ai where they talk about it. They have a how-to guide to actually go and deploy YugabyteDB in multiple regions and across multiple clouds. So definitely worth looking at to see how you can do it. They simplify a lot of the infrastructure operations pieces further. And, again, the key thing here was to show that performance impact is minimal, even when you're running across multiple clouds. So that was the Kubernetes piece. Again, if you have any questions at all, or if you want to talk about how you can deploy Yugabyte in Kubernetes environments of your choice, do talk to us or reach out to us on the community. Either way, we are here to answer any questions that we might have. Now let's get on to some of the other cool features that we have in 2.7, right? Because 2.7 is, again, as I said, lots of interesting, innovative features to make your life simpler. The first one, YSQL table spaces. Now, if you're familiar with PostgreSQL table spaces, these are entities that allow you to specify the location of data on disk, as well as allow you to control options around how that data is accessed. So for example, if you have small, frequently used tables or indices, you can pin them, you can put them in SSD so that access time is minimized, right? So that is something that PostgreSQL provided. YugabyteDB, of course, being a distributed database for us, a lot of the considerations here are in a geo-distributed environment are around pinning to specific zones or regions, right? So we took the concept of Postgres table spaces and extended that to YSQL table spaces. So YSQL table spaces are entities that allow you to specify things like how many replicas you want to keep for a set of tables or indices, as well as where these replicas should be distributed across clouds, regions, and zones, right? So now you can basically create a table space and define replication within that table space. You can define location pinning within that table space. So a couple of use cases that we've seen an immediate use for. One is, say you have one massive table and you want to have that the data in that table be read across different regions in the world. We can basically create duplicate indexes, and we're going to get into that in the demo in a lot more detail, but reduce access latency for a massive table that is mostly read by creating duplicate indexes and pinning it. The other is row-level geo-partitioning, where you have a single table where you have a column that is pertaining to geolocation, and you want to partition that table and then pin it to different geographies. You can do that again with table spaces much simpler. So row-level geo-partitioning, I want to spend a couple of minutes talking about that, right? So this is a concept where you have a single table, and in November 2020, we announced row-level geo-partitioning support in YugabyteDB. So row-level geo-partitioning allows you to take a single table and based on a column of the table, partition it. So you break it up and say you have a geo column which says where is this user located, and based on the value of that column, you can geo-partition a single table and then pin those rows to specific geographies, right? With table spaces, what you're doing is assigning those partitions to those specific table spaces, which are already pre-configured to have geographic affinity and geographic pinning, right? So what this allows you to do is take one table, break it up, pin it to different geographies. This allows you to achieve, so if you have users in all these different countries, you can achieve low read and write latency. And because this is a single YugabyteDB cluster, you have strong consistency and all the goodness that comes with the configuration, but you also have low read and write latency for users in those countries. So for example, if you have a table with bank accounts and you want to pin those accounts to different geographies, you can do that easily with row-level geo-partitioning, and table spaces make the process of keeping these partitions in those regions much easier. And just, I want to take a step back. We did a webinar, I think a couple of weeks ago, specifically talking about our geo distribution capabilities. Yugabyte offers the most flexible and comprehensive set of options when it comes to deploying geo distributed topologies of your database, right? You might want to do geo distribution for resilience. You might want to do it for latency, or you might just want to do it because you need to keep data in certain geographies, right? In all these cases, very often we found that customers have to choose their databases based on what they value most, right? Because a single database doesn't give them everything they need. So for example, you might have data that needs to be strongly consistent, right? How do you make sure that you're able to deploy in a geo-distributed fashion while maintaining strong consistency? Or you might have other data that can have eventual consistency, but you want to have super low latency. So Yugabyte is giving you all these things in a single database, right? So you can basically make those trade-offs between consistency, latency, read latency, write latency. So for example, if you need strong consistency and you want to have region level resilience, you deploy a multi-region stretch cluster, right? So you can basically have a single Yugabyte cluster with the nodes in different regions. So you're getting strong consistency and you're getting, you're going to have high latency because now the nodes are sitting, in like a 40 to 100 millisecond distance from each other in terms of latency, but you're able to do that with strong consistency and get region level resilience, right? So these are just, this is a quick summary of the capabilities available in the YugabyteDB platform database. So would definitely recommend, if you are interested in this topic and want to learn more, go and check out the webinar we did, which was engineering around the latency of physics of latency, talking about geo-distributed databases. Right.
And
Yeah. Go ahead.
right.
Yeah.
Just to add to that, right, we have comprehensive documentation on all of these 6 ways of deploying Yugabyte, as well as a lot of innovative blogs and thought leadership that we do on our website, as well as the blogs, to ensure that your workloads, I mean, you can actually see how our customers are using these different topologies in a way that they can meet their business SLAs by using a combination of some of these. The best one, I mean, the most innovative one that we can talk about right now is geo-partitioning. And that also provides a segue into the next slide. That is, with our work over the last 6 months with row-level geo-partitioning and YSQL table spaces, you can actually meet some of your data residency compliance requirements when it comes to making sure your data is sticky to a single zone or a single data center, even though you are using Yugabyte in a distributed topology way. So those are the hooks that we provide you to meet your compliance requirements, and something that you can build on top to achieve compliances like GDPR or CCPA and others as well. So we're going to spend about a couple of minutes to do a demo of how YSQL table spaces would work. Thanks, Sudha. Let me quickly share. Okay. And as you can see, what we have done in this demo is that we've actually created a multi-region deployment cluster of Yugabyte. And if you look at around, how exactly this cluster has been deployed, that is, it's actually a replication factor 5 cluster. So think of it as there are 5 different fault domains that are currently present in this cluster, out of which the US East one, which is a main data center in this case, it essentially comprises of 3 nodes. In US East one, it comprises of 3 nodes where latency is less than 1 millisecond because it's a single region. Amazon latency is routinely less than 1 millisecond for a lot of them. We also have a second region that is essentially in US East 2. The latency between US East 1 and EU West 2 is usually 75 to 80 milliseconds in Amazon's case. Then we have AP South as well, wherein the latency can go above, I mean, sometimes it does touch close to 187, 188 milliseconds that way. And routinely we look at 113 milliseconds between Europe and Asia in that case. Now, taking this concept ahead, and I'm going to take the opportunity to walk you through how Yugabyte platform has been designed with the database reliability engine principles that we had talked about before. That is, as we mentioned, Yugabyte platform is a containerized web application wherein when I log in as a super admin, the way I'm logged in right now, your operators and DevOps team can go and configure any or all of the cloud options that are available for your teams. So let's say I have access to Amazon through IAM credentials, Google Cloud. Very soon you're going to GA, Azure, and OpenShift. So these beta tags will go away. Or if you have any other Kubernetes, let's say VMware Tanzu, OpenShift, or any other Kubernetes vendor of your choice, you can select that. Or as we had mentioned before, any virtual machines or bare metal environment, if you can configure those machines and provide us a CIDR block, you can essentially go and deploy Yugabyte on top of that. Similar to that, you have encryption at rest or encryption in transit that you can bring across the board. Once you do that, you essentially can now deploy Yugabyte on top of any of those cloud providers or all of those cloud providers if you want. So for this demo today, what we have done is, as I mentioned, we have created a replica RF5 cluster with 7 nodes in it. And the topology looks something like this. That is, essentially, we have 3 nodes split in US East 1A, then each node in US East 1B and 1C, 1 node in US West 2, and 1 node in South Asia. That way, it's a replication factor 5, 7 nodes, pretty simple config because we're just doing the basic demo here, like 4 cores and 8 GB RAMs across that. And when we look at the tables, how they are laid out, let's look at one of the tables, which is a multi-region table, right? And a multi-region table scenario, you'll quickly see that this table is now sharded across all the geographies that are essentially part of this deployment, so that I can actually afford to lose 2 data centers in an RFI deployment. 2 data centers can be lost without hampering the data consistency or losing or having a downtime to your end application. So that's the most important part. And if you are interested in taking a look at how exactly these tables are sharded, you can just go on to the universe again, click on how exactly my master is sharding these tables in terms of metadata. Click on the tables, and now you can see that in a multi-region table that we have created, there are essentially 5 replicas, and you quickly see affinitized leaders, how exactly they're spreading across different geographies, and how exactly we take care of sharding and rebalancing the data using Raft as a consensus algorithm. So this assures you data correctness and strong consistency that is provided by Yugabyte out of the box, and you don't have to worry about any of these deployment topologies because Yugabyte takes care of that. Now, imagine you couple your microservices with this value, you essentially don't have to worry about your stateful data layer at all. And you can adhere to your DevOps best practices in routinely doing scale up, scale down, rolling upgrades without any downtime. That's the core benefit that we provide to users like yourselves in bringing these new features to the table.
Perfect. Thanks, Amey. No, that's good. Table spaces, again, new capability that builds on stuff that we already have in the database, right? Geo-partitioning existed, table spaces turbocharges that, allows you to easily manage, more conveniently manage where you place your data and how you replicate it and how you access it. Right. All right. So very quickly, let's just continue like this, Amey. So point-in-time recovery, right? This is similar to the flashback concept that you may be familiar with in Oracle. So it's a feature that allows you to investigate and recover from unwanted database changes. So for example, if someone accidentally drops a table, or someone accidentally overwrites or corrupts the data, or you have a situation where for some reason a table got batch process did not complete, and so you have kind of an intermediate corrupt state, and you want to roll back your database to a previous state, that's where you would use something like point-in-time recovery, right? So it gives you granular data protection with a very low recovery point objective and pretty much no impact to the cluster, right? All of this is happening within the data, the docdb layer, which is the storage layer in the YugabyteDB cluster. So we're not copying the data off or somewhere. So the way it works is docdb is a log structured database where each of the changes to a specific data value are tagged along with the timestamp when that change happened, and that is stored in the underlying database, in the underlying storage layer, right? So it's basically keeping a track record of all the changes that are happening to a value like a table or a row or something. So when you enable point-in-time recovery, you would set something called a retention target, which is basically signaling to the database not to delete any of those changes, right? So the timestamp and value, it's basically asking the database to keep those that train or that the chain of values, so that you're able to restore to a particular target timestamp in the past. And the way it does it, it just goes back to whatever the value was at that point. So TS3, for example, if the target value is that orange dot there, it goes back to TS3, which has value 3, and then discards everything beyond that, all the changes beyond that, right? So that basically takes the database back to a point in time. And now you can do that in a very convenient way as part of the platform interface that Amey showed recently. So you can restore it both to an absolute point in time in the past, so restore it back to, say, like Monday at 11 a.m., or you can restore it to a relative time in the past, which is like restore it by 3 hours in the past. Because if you're actually working on changes right now, or you're making batch changes, when you started the batch job, if something failed, you want to be able to restore to right before you started that process. You can also kind of recover from a snapshot and then use that snapshot as a way to go back in time from there, right? So Amey, you want to add to this?
Yeah. So folks, the main point here is that the point-in-time recovery is happening on our storage layer. That's the docdb layer. And that's why both the APIs, YSQL as well, YSQL is going to piggyback on that functionality. Now, routinely, it takes database vendors years to build these type of features. But since Yugabyte has been developed in a modular way, it was very easy for us to go and get point-in-time recovery done on the snapshot level on docdb. But we would love to get your feedback on what new things you would like to see in this feature as well. So this feature is now available for you to go and test it. Please provide us feedback with your testing on what kind of scenarios that you can think of where point-in-time recovery will be absolutely necessary. I mean, some of the scenarios or use cases that Sudha mentioned, like business continuity or accidental deletion of data from an app developer, you can now go back in time and do that. We'd love to hear from you. What are your RPOs and RTOs that are essentially required to meet your business objectives? And based on that, we can collaborate with you as a design partner in building these features in a robust way.
Perfect.
Yeah.
So the next feature is our support for the Apache Kafka sync connector, right? So Apache, the Kafka Connect is a framework that allows you to stream data between Kafka and other data systems. So you could have a Kafka sync connector and a Kafka source connector. A source connector allows you to take data from different databases or different data systems and send it into Kafka streams, right? Or Kafka topics. And similarly, a Kafka sync connector allows you to take data from a specific topic or a specific Kafka stream into a third-party database. So what we are supporting now is a YugabyteDB sync connector. So it allows YugabyteDB to be the destination of data that is coming out of one or more Kafka topics, right? And so this could be useful, for example, if you have IoT data or clickstream data that you're collecting from different sources, and you want to send it all into a YugabyteDB database in the back. It could also be useful in a microservices environment where you have databases associated with different services, where you want to have changes happening in one database be funneled into another database, right? And this could be YugabyteDB, which is the database behind one or more microservices. So change data capture allows you to take changes from one and send it to another so that you can kind of have multiple databases that are essentially communicating with each other. And the third one is CQRS, which is a design pattern that allows you to have different models for the way data is ingested into a database and how the data is actually queried or consumed from it, right? In all these cases, you have a situation where you have one or more data sources that are funneling data into topics that are then consumed by a database in the backend, right? The cool thing about the YugabyteDB sync connector is that because YugabyteDB is a distributed system, you can actually scale a YugabyteDB cluster by adding nodes. And similarly, the Kafka Connect sync, you can scale by adding additional workers. Now, because you have scale out in both these places, our sync connector essentially allows you to make full use of that parallelism, right? So you're able to increase the throughput by scaling the YugabyteDB cluster and or scaling the Kafka Connect workers as well, right? And all these workers can now talk to different nodes in the YugabyteDB cluster.
And again, a lot of our current set of users use event-driven architectures where Kafka is the lifeline of those kind of architectures. And a lot of our current customers, like the ones which are in IoT space or retail space or even automotive space, like one of the top 5 largest automotive maker in the industry does use Yugabyte for that. The telemetry data and everything is flowing through Kafka. And that's why we have benchmarked. We routinely benchmark our Kafka sync connectors to make sure that we provide that linear scalability and ensure the performance and SLA that is required for these kind of application architectures as well. So again, please work with us if you have any other non-Kafka related event-driven mechanisms like Apache Pulsar or others that you're interested in. We're happy to collaborate with you because it's a pluggable layer that we have built on the lower end of the database itself.
Yeah, and to talk more about the throughput, one of the things that our performance engineering team has done is benchmark. So actually run the test by scaling the number of YugabyteDB nodes and the worker nodes and see how much performance we're able to show. And we were able to hit like over 110K messages per second by scaling both sides, right? So the scale out architecture works in favor of being able to scale the number of messages per second that's going through the pipes.
Now, continuing with the train of thought, in terms of enterprise hardening, as I mentioned to you folks before, the Yugabyte platform is a console which basically provides you a way of launching your own Yugabyte as a service for your organizations. Now, since this is it's a single pane of glass, we wanted to ensure that you get the benefits of not having this as just a single point of failure, but actually running it in a active or a multi-deployment topology as well. To that, one of the core things that we have built in the current iteration of the product is to go and enable high availability for the Yugabyte platform console as well. So you can now run it in active and standby mode with a manual failover for this release iteration. And very soon, we will be working on like a synchronous active-active style topology as well. But this is how, even though Yugabyte platform is not in the critical path of running your stateful workloads with Yugabyte, you still have confidence that you can run it in a multi-topology way, or like active passive way, without hampering your DevOps automation in that case. So again, one of the core things that we're just bringing to the table so that all of our customers can confidently run their Yugabyte workloads with the observability and manageability principles there. So that you want to take this one?
Yes. So the other thing is data encryption, right? Security is a super high priority at Yugabyte. We provide a number of capabilities out of the box that allow you to deploy and run and protect your data, secure your data in a YugabyteDB cluster. One of the things we offer is support for TLS v1.2. So in transit encryption of data between clients and servers and between different servers of a single YugabyteDB cluster, right? So in a distributed system, you have to think about encrypting data from client to the servers as well as between the servers of the cluster. Now, one of the concerns that always comes up when you're talking about security is what is the performance impact going to be of enabling something like TLS encryption in your cluster, right? Is it going to really affect the data throughput or data performance? So again, our performance engineering team, Taylor Moll, who's on our SE team, actually ran tests. He went and did TPCC benchmarking to see what the performance impact would be of enabling TLS versus not in a YugabyteDB cluster, right? So he basically went and turned it on. He wrote a blog post about this as well. What we found was that by enabling TLS, your performance impact, so throughput drops by less than 5% versus if you're not turned on TLS. And the average latency increases by 15%, but there is a 10% variance anyway. So it's kind of within the margin of error when it comes to doing cloud runs of TPCC, right? So he'd actually had a multi-zone deployment, I think, and was able to show that the average latency is also, within the margin of error, within 5% drop in performance. Similarly, CPU utilization, again, is within the margin of error. So you're basically saying performance impact is minimal when you enable TLS. So you can go and secure your data, turn on data in transit encryption, and basically get pretty much the same performance as you would without TLS, right? And there's a very good blog post that we will send a link to that actually has the details of the test that was run. We welcome you to actually go and run these tests yourself and see for yourself, right? All of this is available. Also, how he set it up and what configuration he used is spelled out in that blog post. So definitely go check it out and see if you want to replicate it.
Correct. And one last thing I wanted to add here is that routinely it gets tougher for folks to go and enable SSL in databases, but we have simplified that you can either let us generate the CS certs or you can bring your own certificates, and we have a very simplified workflow of doing that through Yugabyte platform. Even though your clusters are running in multiple regions or multiple clouds, we take care of providing the simplified workflow for you. So that is, again, another innovation that we have done in the industry. Also, we adhere to the best, most latest TLS v1.2, so that there were known CVEs at TLS 1.0 and 1.1. They are all not at all affecting Yugabyte from that standpoint. Now, in the interest of time, we wanted to basically also present you what we are currently working on. That's going to be we will be bringing to you in like next 2 or 3 months. And again, as I mentioned before, our entire roadmap is open source. If you go to github.com/yugabyte/what's being worked on, you exactly see what all features we are working on. You can routinely track any of these features to, let's say, if I click on point in time restore, you essentially get the entire information of how exactly this feature is being developed by our team, how we are going to be hardening and all those things. And we love feedback from you all to make sure that we continue doing the innovation and bringing these features and benefits to all of you. Now, that being said, these are the core things that we are currently working on as an R&D and product team. That is, first thing is, we are one of the top most vendors, or like the only vendors in a distributed SQL database industry who's bringing a capability of a smart JDBC driver. That is a driver which is cluster and topology aware, so that you don't have to worry about how exactly your database is being deployed. We take care of providing your single hop fetch or a single hop put to your database by eliminating any intermediate load balancers. So that's the innovation. I'm going to talk about that in the next slide, and we are open to design partners and contributions on that one as well. The second thing is, as we are maturing into the industry with brand new use cases with YSQL API, we are also bringing in the capability of doing generalized inverted indexes. That is, the Postgres gen indexes on top of YSQL. This also provides you building blocks to do text search style use cases in the future. So this is a stepping stone for us to go gather those use cases And in future, we will also bring in GIST indexes as well as the geospatial query support as well. But these are the fundamental building blocks that are required to achieve those kind of things later in the year. The third thing is we have a whole bunch of users who are in EMEA and APJ and different parts of the world who do not use the default Postgres coalition of type C. So that's why we are bringing you the internationalization or coalition framework support as part of the YSQL API of Yugabyte, so that you can now store and query your data in the choice of coalition type that you would want. This is very important for a lot of our European and Asian customers who routinely go and query their data in a very different way without using type C as a method. In the last release, we took on the onus of doing LDAP authentication and making sure that your AD and LDAP can be integrated seamlessly with Yugabyte's YSQL API. In this iteration, we are extending that concept so that you can now have Kerberos authentication and GSS API as well integrated for providing a single sign-on style capability with Yugabyte for all of your users. Again, as we mentioned before, we have a pluggable authentication mechanism here so that if you have any other authentication mechanisms of your choice, we're happy to work with you and provide that integration in Yugabyte as well. The last one, it's always a continuous journey for any database vendor in the industry. That is, we are very true to ourselves when it comes to performance. We do a nightly CI/CD, as I mentioned before, for all of our TPCC and YCSB workloads. And now we are starting to invest on a cost-based query optimizer, which will also account for things like network latency between nodes and all, which routinely Postgres had never had to deal with because it was a single node concept. But now Yugabyte is a distributed SQL Postgres database. We make sure that we start looking at some of these vectors so that they can be included while computing the cost of the query plan. In terms of the innovation that we're bringing to Yugabyte platform, which we mentioned is a manageability console, as well as provide you to the day two automation, the database itself, we are getting the market signal to make sure that all of our APIs are available to public consumption, so that you can do your own Terraform style automation or any other automation or CI/CD pipelines without doing ClickOps style deployments with Yugabyte platform. The second thing is we have invested heavily to making sure that our current alerting and metrics and monitoring framework can be now extended to different third-party applications, as well as providing fine-grained granular controls on some of these monitoring and metrics options as well. The last thing we already touched upon, that is, we have a set of users who use Azure and OpenShift all the time. We heard their request and we made sure that within the next few days, we will be making these two platforms generally available. So these have been running in beta for about 4 to 6 months now. This will be generally available in the next 2.6 version of Yugabyte's stable releases series as well. Now, the smart driver capability that I mentioned before, this basically provides you cluster awareness and partition awareness, so you don't have to rely on external load balancers, as well as we let the Yugabyte client application drivers go and make sure that the routing is handled natively. So that's one of the core important things for our users to provide low latency, high throughput access for their microservices and application workloads that way. The other collaboration that we are doing is with VMware. That is, as you folks know, most of the enterprise workloads consume Spring as their core microservices framework. So we have been collaborating with VMware engineering to have a first-class support for Spring Data Yugabyte that will get you all the benefits of Yugabyte, like geo-distributed workloads or row-level geo-partitioning, follower reads, table spaces. All those things will be provided to you as annotations so that from your Spring microservices, you can get the best of Yugabyte without having to write your custom code. This is very important for your multi-cloud and multi-Kubernetes story, as well as doing your, as you all know, Yugabyte does provide you distributed asset transactions. Whenever you deploy in a single zone, multi-zone, multi-region, it doesn't matter to us. So this is how you can do your system of record microservices with Yugabyte and Spring as a combination. Again, this is one of the core things. If you're interested in this topic, you should join the topic-spring channel on your community Slack, and you'll see a lot more innovation and goodness that is coming in day to day from this collaboration with VMware.
Perfect. Thanks, Amey. And as promised, folks, we packed this session with a lot of content, and I've tried to answer some of the questions in the Q&A. For the others who we've not answered yet, we will follow up with you afterwards. We do want to leave you with one thing, in the famous words of our master demoer, one more thing. So we have been behind the scenes, we've been kind of working on scaling our TPCC benchmark, right? And our latest results, we're happy to say, is we were able to run the TPCC benchmark with 100,000 warehouses, which is a massive achievement for a distributed database. And we did that on a single 69 node cluster. So we did not have to do any of the partitioning of warehouses or anything that vendors typically do to kind of manage that scale. So vendors end up doing allocating warehouses to specific nodes in the cluster and running it dedicated. We just did it on a single 60 node cluster. And the other thing is all the changes that we made in kind of achieving this benchmark are things that are applicable to everyone. So these are not race car numbers. These are not your Formula One numbers. These are numbers that are street ready, right? That means that if you're deploying YugabyteDB, you're benefiting from this benchmarking work that we are doing. And we're going to continue to, of course, push the limits on this. Not enough time to actually get into what we did here, but if you're interested and want to learn more, definitely reach out to us. We are ready to have a conversation on that.
And just adding to Sudha's point, if you're interested and passionate about solving these hardest problems in the industry, we are hiring heavily on all the fronts, especially the performance engineering side as part of the product team. So please reach out to us on yugabyte.com/careers. We are hiring worldwide at this point. So anywhere you're based, you are welcome to work for Yugabyte in that sense.
Perfect. Yeah, go for it. Yeah. So we are an open source database. We love our community and we love GitHub. So if you are on GitHub and you like what you hear, you like what you've been doing with Yugabyte, give us stars. We like them. And join our community Slack. That's where all the action is. That's where we are having conversations. The community has been growing by leaps and bounds, and we would love to see you there and continue this discussion on any of the topics we covered today.
Right. And the last thing I wanted to mention is that we have this soft concept called Unicorn Club, wherein all the customers who do more than 1 billion operations or billion transactions a day with Yugabyte today are part of this club. So if you look at some of the household names like Plume, which monitors all of your routers for if you are a Bell Canada or Xfinity customer, or Xignite, which basically powers most of the trading applications in the industry, CipherTrace for crypto anti-money laundering, or Narvar for your retail or shopping tracking. These customers do more than 1 billion transactions a day with Yugabyte. And we would be welcome to see some of you folks participating and achieving the scale with Yugabyte and actually meeting your business SLA or overachieving your business objectives with us as well.
Perfect.
So that, thanks again, folks. We are just about on time, I would say, Sudha.
Perfect. All right. Thanks, everyone.
Thanks you.
Let's continue the conversation. Bye.